Hello, everybody. My name is Gary Shi. I'm a principal software engineer at Microsoft working on the Babylon team. So today I'm going to be talking about the latest development of what's been happening with Babylon.js. I have a lot to cover, so I'm going to just get right to it. So I'm going to be talking about three things. First, just a quick overview of Babylon in case you haven't heard of Babylon before. And then I'm going to talk about the latest developments in the latest version of Babylon 7.0, and then a bit about what's coming next. So let's start with a really quick history lesson, in case Babylon is new to you. This was sort of mentioned in Neil's sort of timeline already, but back in 2011, when GPUs became more available on devices, browsers got together and agreed on an open standard that allowed for communication with the GPU called WebGL. And as time went on, it was becoming really clear that while WebGPU is really powerful, it was really hard for people to actually use it directly. Right? And so, how can we reduce the barrier to entry here? And that's why Babylon.js was created. It's a simple API that sits on top of WebGL. It is easy to understand and use. And it's familiar to web developers because it is using JavaScript. We have an easy to access learning resources such as great documentation, friendly community, as well as a very active forum. Each person on the team actually rotates through every day and tries to make sure that all answers are questions. All questions are answered. And of course, this is a thing that's really a pillar for us, is that we are backwards compatible, which is very different from other JavaScript libraries because we try our very best to make sure that existing code still continue to work, even after major updates. Okay. Now, this is not 100% true all the time. We have bug fixes, things that will break certain things, but for the most part, all the playgrounds, all the things that you've written will still continue to work even in the latest version. And so after 11 years of development, Babylon.js has grown into an enterprise-grade professional development platform with a clear mission. And this is our mission statement: build one of the most powerful, beautiful, simple, and open web rendering platforms in the world. Now, these four pillars, powerful, beautiful, simple, and open, they help guide us in our decision-making as we continue to evolve the platform. Today, Babylon can be described as an open source development platform, a JavaScript engine built entirely on open web standards like WebGL, WebXR, of course, glTF, and others. And it's a fully featured game rendering engine that supports things like haptic physics, animation, XR, you name it, right? As well as advanced physically based rendering. We also have another tech called Babylon Native, which unshackles the developer from the browser. You are now able to write once in JavaScript and run it everywhere, including native and web. The rendering code that you write in TypeScript, JavaScript runs also in Babylon Native, right? It's using the same rendering API. One of the scenarios that people are trying to do with this tech is run in a headless environment. So for example, you can take, let's say, screenshots from a server or generate videos on a server and do it in a sort of isolated way without a browser. It's sort of taking up more memory or whatever it is, and then serve it to the client. So that's just really quick about Babylon Native. I won't be able to talk about Babylon Native much in this presentation because that will take quite a bit longer. And we're really humbled by the fact that Babylon platform is trusted and used by organizations, developers all around the world to bring remarkable experiences to life. Right? Some of the innovations we've seen by some of the companies here are really, really amazing. Right? But one of the questions that people sometimes just ask us when they're evaluating Babylon is, Babylon is open source. How do I know I can trust this platform? How do I know it won't just get abandoned after 6 months? Right? And the way we answer that is, even though Babylon is open source, we are fortunate in that Babylon's development is fully funded by Microsoft and has been for the past 7 years. Microsoft invests in Babylon's development for two specific reasons. All right. One, Microsoft is a believer and supporter of open source software. Microsoft sees Babylon as a technology that can make the web better. Right? And two, Microsoft uses Babylon to power over 50 features across 15 products. And that number continues to grow daily. So Microsoft isn't just philosophically supporting Babylon. Many Microsoft products depend on the Babylon framework to survive. And we continue to help lead the future of web graphics for the others in the industry. And so that's a really quick overview of what Babylon is. Let's take a look at some of the latest features in Babylon 7.0. So Babylon 7 was released early this year on March 28th. And it is one of the most feature-rich releases to date. It had many, many different contributions from the community. So here's that list. We have things like global illumination, we have ragdoll physics, grease line, things like that. And I'm going to try and demo some of these live for you today, which pretty much. So first, I think people know what precision geometry is already, but this is sort of what Babylon is doing with it. We call it the node geometry editor. So let me try and show this here. Yeah. So here we have the node geometry editor. And what you see here is just a box. Oops, what's going on here? Okay, so you can rotate it around and you see the preview, right? And so what I'm going to do is I'm going to try and create a generated terrain with some trees on it. Okay. And so to do that, what I'm going to do is create a grid, and we're going to connect it. Now, by default, a grid is just two triangles. That's not really useful. So what we want to do is tessellate it a bit more with more subdivisions. So let's go with 25, let's say, and make the width a bit bigger just so that we can have a bit more real estate. So that's good. So now we have vertices in a grid, but what we want to do is vary the vertices, right, on the island top. And so what I'm going to do is add a new node called set positions, just like that. And then, without actual positions being entered, it doesn't actually do anything yet. So I'm going to add a positionals node and a normals node. Now, okay. And then what I'm going to do is add them together using the add node. So I'm using a trackback. That's a bit hard to do. Okay, so you saw it kind of jumped up, and it jumped up because the normals are 1, and I'm just adding them together. So that's not quite what I want yet. What I really want is to add a bit of noise so that I can generate a string. And so what I'm going to do is add a multiply node. Oops, close. And I'm going to add a noise node. And just like that, you now have a terrain. Right? And you can tell that this is dynamically generated because I can change some parameters of the terrain and it will subtly move. Same thing with the roughness. But you'll see if I change the shader to be sort of shaded as opposed to wireframe, it's all white. And that's just because the normals are all pointing in the same direction, right? So you can add a compute normals node, and now it'll compute the normals. It's still a bit hard to see, but if I change it to this mode, then you can kind of see, okay, now the normals are correct. Right. Okay, so let's create some trees. If you want to place the trees, create a pretty simple tree. Let's go with a cylinder. Move it down a bit. And I'm about to create a icosphere, sorry. And what I'm going to do is merge these two geometries together. Okay. Now you can't see anything because I haven't actually connected to the geometry output. So I'm going to do that now. Okay. I'm going to go to wireframe. You can see there's a sphere inside a cylinder. Now, this is great, but obviously it doesn't look like a tree yet. So let's change some parameters. The diameter needs to be a little bit smaller. Let's go with 0.1. Yeah, that seems about right. Radius maybe like a bit bigger. 0.3. Okay. And, the sphere is not in the right position, so let me move that up a bit. And so what I can do is add a transform node and add a translation. I don't know, that looks like about 0.5 or maybe 0.6. Okay, all right, so 0.6, and now I have a tree. Now, obviously, it's a very simple tree. Amazing tree. Or lollipop, yeah. So for the sake of time, I'm not actually going to do the rest of the demo. What I'm going to do is show you one extra node, which is instantiate on vertices. And if you create one of these guys, you can then instantiate this model on each vertice of another geometry. And you can do that by clicking these up, but then you can also change the density so that it's not on every single vertex. It will randomly select the right ones, or not the right ones, but randomly select one. Sorry, gotta get rid of this. And so let me show you the end results. The end result, if you clean everything up and you do some sort of some randomness, you'll get this. Right. And you can see that. Let me maybe pause it for a second. So let me zoom in real quick to the noise. Oops. Sorry, but with the trackpad again. Come on. So if I change the noise parameters, I'm sorry, it's over here. If I change this to 1 and I slide this around, you can see that it's actually procedurally generated. It's just constantly changing. Right?
We can use seeds.
Use seeds? You can use seeds if you want. And for a more complex solution or a complex example, you can scan this QR code if you want to see it for yourself. This is basically generating a city block with a bunch of buildings. And these buildings are procedurally generated completely. There's no downloading of assets, right? And it's just, building everything up completely at one time. Let me go back to my presentation. So we have a few other procedural features. One is what we call no material editor, which is a procedural material, which allows you to create a custom shader using the similar techniques using nodes and combining them together. I'm not going to demo that here because that's been around for a bit. There's a bunch of documentation and YouTube videos on that already. But I want to point out that we're also working on procedural behaviors. And this ties in with a new KHR extension, KHR interactivity. And so we've been following that spec, making sure that, we can actually handle the things that they're going to eventually put in the spec. And so we call this the flow graph. And again, similar to other kind of node-based features, we have a bunch of nodes and we can connect them and then have logic in your scene that is not code, right? It's similar to Unreal blueprints, things like that. All right, so let's talk about Gaussian splatting. We have support for this. It's pretty basic. It allows you to render the Gaussian splats. We support plies and splat file formats. And of course, I think people already know this, but Gaussian splat is able to render sort of furry things much more accurately than you did it with mesh. Right. So I'll just show you a quick example of this in a carousel. The person who captured all these with Luma AI was really into pirates, so it was Pirates Airbnb. Maybe not the last two, but yeah. And so, all right, this is the vector, as you can see. Yeah, that's right.
Pretty easy to get that. Yeah.
Oh, interesting. How did that happen? What were you seeing the node? But not this?
Yeah. Like, not all.
I got it. I forgot to press escape. Yep. There we go. All right. That'll make some sense. There we go. So the parrot, more pirates, layer wires. You can see it splats back here. You can tell that. The back with the capture and the vector. Okay, so let's go back to the implementation. Okay, so we can now render Gaussian splats. One possible use case is suppose a customer wants to buy a fur rug, okay, and they want to see it in a room. Right? This is sort of the typical e-commerce scenario. I want to see it in a room. Right? We can now combine Galaxy splat rendering with XR and take these two together and show the rug in the room. Now, this would have been a lot more difficult and or more expensive to render using existing techniques. Right? If you have an Android phone, you can scan this QR code and try it yourself. Unfortunately for iOS, they don't support WebXR yet, and so you can't do it on an iOS phone. But hopefully we'll get there soon. So I won't be done with this because it'll be really hard for me to do this with an Android phone here. All right, so let's move on to decals. We have a new feature in 7 called seamless texture decals. But just to make sure everybody's on the same page, I'm going to go through some sort of historic things as well. So again, make sure I press escape. So this is not new. Everybody probably knows what mesh decals are, but basically it's creating a mesh and projecting a texture onto another mesh. Okay. And so you can see if I use the inspector to show this, let me move this over a bit. You can see that these are individual meshes, okay, if I show the bounding box for that. Right? Now, there's pros and cons to each one of these approaches, but one of the cons to this approach is that each decal is a separate draw. Obviously, if you have lots and lots of decals, that's not good for performance. Another thing that might be bad is if your model that you're projecting to has a lot of vertices. Right? If lots of vertices, the decal has to walk through every single vertice in order to project each one. Right? And so that's why there are texture decals. And texture decals is a bit different than mesh decals in that it will write into a texture instead of a separate mesh. It will write one texture, and that texture sort of overlays on top of the existing rendering. Right? You can see that by seeing here that there are two materials here, and one material is overlaid on top of the other. Now, what I want to point out here in this example is that this mesh is actually incredibly dense on purpose, just so that we can show this. It has almost 3 million indices and almost 900,000 faces. And yet, performance is just fine, right? Because it's using texture decal. Now, again, there are still some problems with this. If you have UV islands, okay, then it also doesn't quite work correctly. So here's a model that has been scanned, I believe, and therefore there's some UV islands, okay? And you'll see that if I put decals on this one, you'll see some seams. So this is actually the feature I want to show you, in that a community member actually contributed this fix. And they basically added a flag to allow blending between the UV edges. Okay, so if I turn this on, all the edges disappear. Now, the reason why it's under a flag and not just always on is because the GPU still has to do a little tiny bit of work to do this. So if you don't have UV islands, you don't want to turn this on. But effectively, it's blending between the edges. Yeah. So that's decals. And lastly, I want to kind of show you the state-of-the-art glTF support. Oops. And so these are some of the newer extensions that have been ratified recently, as well as one that hasn't been ratified yet. And so this is the anisotropy extension, and it kind of allows you to create kind of the brushed metal look. And I just want to show you this. You can see that the light behaves a bit differently than sort of normal non-anisotropic. And I will show you that by turning it off. So if I turn it off, then you can see that it behaves different. Right? Oh, sorry. This model was created by our very own Eric Chadwick. So, this one is the dispersion extension, and it's a little bit subtle, a little bit hard to see, but you can tell that it's kind of like the prism effect when you have a light that goes through a prism and the colors separate. And this model was created by Ed. He just added a one to an existing model that he created. And so you'll see that it's kind of in the volume sort of refraction. You'll see a bit of color dispersion. Okay. And again, I can kind of turn it off so that you can see it a bit more. I can turn this screen off. If you look right here where my cursor is, like these color changes, you can see that it turns off. Right? Okay, and lastly, this one has not been ratified yet, but the PBR working group from Kronos, we're working on this one. But again, this is a model that's generated by Eric Chadwick, and thanks to that. Thanks to him. This is a really cool model. We have some beads with a point light attached to them. And the point of this diffuse transmission is that you can basically have the colors show through a thin material. Okay, so we can even change the camera to be chasing the bead, right? And you can kind of see that. Yeah. So thanks to Eric for that. That was a great model showcase. Yeah. Yeah. All right. So that's Babylon 7, 7.0. Let's take a look ahead and see what's next. So hopefully you probably have heard about WebGPU already. It's sort of the next evolution. You know, WebGL1, WebGL2, WebGPU is kind of next. And WebGPU can do something a bit more than what WebGL2 can do, namely compute shaders and snapshots. Compute shaders, probably many of you know this already, but you can, instead of using GPUs to do rendering, to do vertex and pixel shading, you can just make it do math, right? Do some things that are not related to rendering, right? And snapshots are a way of reducing the overhead. You can basically capture all the commands that you want to send to the GPU, save it in an object, and then replay that exact set of commands in the next frame. And it will save a whole bunch of time trying to send WebGPU commands. Oh, sorry, no, well, WebGPU commands, any GPU commands, really, right? And so let me show you a demo where it's using compute shaders. So this is simulating an ocean, the ocean waves using compute shaders. I like to play with this a lot because it's really fun. I like to change the wind, go crazy, and have the peaks go nuts, right? And then, I get sore, and I'm like, I'm gonna drown, right? And I'm kind of so. This is all running at 60 per second on my 5-year-old MacBook Pro, right? So it works really well. So just a couple of things I want to announce really quickly. Just hot off the press, I don't know if people know, but WebGPU actually uses a different shading language. All right, so WebGL uses GLSL, whereas WebGPU uses how we call Wigzl, right? And so there is a way to translate GLSL to Wigzl, but you have to use this extra library that's in WebAssembly that's kind of like 2 megs, 3 megs to translate, and it takes time to download. It also takes time to actually do the translation, so it's kind of painful and annoying, right? So what we did is we said, okay, that known material thing that I mentioned earlier, let's generate Wigzl directly. Okay, and so that just got merged, and hopefully everything will work out, and now you can choose whether you want to generate GLSL or Wigzl. Another thing we're working on is converting our core PBR shader to also just directly go to Wigzl as opposed to GLSL, so that you don't need that translation. That's my talk, and that's what's been going on. I know these links are not clickable, but we'll be sharing the deck after the talk, and then you'll be able to click. So, thanks.